So this computer gives the population of Naples, Florida from 1960 to 2020. Now, exponential growth is a previous model we looked at, and that's if something can grow without bound. But there's only so much property in Naples, Florida, so eventually you're going to hit a maximum point. It can't grow beyond that. So it may start out growing very, very quickly, but eventually it's going to stabilize. And in that case, the logistic model is better for us to use. So I've got numbers starting in 1960, ending in 2020, and it is suggested that you use t equals 0 for 1960. So if that's the case, we're going to make a table. T on one side, population on the other. So 1960, t is 0 when the population is 4,700. So this is how the table starts. And you'll notice it goes up by 10 every year until we get to 2020. So what is that? 60, 10, 20, 30, 40, 50, and 60. So we're going to go ahead and look at the populations of those and fill those in on our table. So we had 4,700, 12,000, 17,600, 19,500, 21,000. You may notice there's a dip from 2000 to 2010. I want to remind you that there was the Great Recession in between that certainly caused a lot of upheaval in the country. So we have our current table. Now we want to put those numbers into the graphing calculator. So I will do that. Let's go to the TI calculator. Clear what was there before. Stat edit. Oh, I have things that were there previously, so clear the stat, clear list. I'm going to clear list L1, enter. Stat, clear list, L2. You could, of course, just type over what was there before. That works, but that's the actual process. So I've got these numbers I need, 0 through 60 on the left. 0, 10, 20, 30, 40, 50, and 60. And then the numbers on the right are much larger, 4,700, 12,000, 17,600, 19,500, 21,000, 19,600, and 22,367. So those are our numbers. I like to look at them to get a feel for how they are growing and changing. So I'm going to go to stat plot. I'm going to turn it on. Click it that way. So second stat plot is what I need to do. It's on, which is good. The X list is an L1 as I typically use it. The Y list is an L2. That mark is good. That looks good. And then what do I need? I'm going to just go ahead and go zoom stat, which is number 9. And it shows me those dots. Notice it's growing quickly, then it's starting to stabilize. That is one model that we can use with the logistic. The logistic is helpful for us in this example. So let's go ahead and find the logistic regression. Stat calc. I have various regressions here, linear, quadratic, cubic, quartic, another linear, log, exponential, power regression, logistic. There we go. There's my logistic regression. The X list is L1, the Y list is L2. Frequency, no, there's no frequencies here. I'm going to store this in Y1, vars, Y vars function. It's going to store it in Y1. And I'm going to calculate that regression equation. We'll look at it. What's it give me? It's thinking. All right, so it's a little hard to read this. Y equals C over 1 plus A e to the negative bx. I want to make sure you're clear on that. So I've written on the paper again, y equals C over 1 plus A e to the negative bx. So what are A, B, and C that they're giving us here? A is 3.2369. B is 0.14157. C is 20,953.6, which I was going to round up to 20,954. Interesting number, because that tells us that essentially Naples has gone beyond its maximum value, its carrying capacity. Interesting. Okay, we can look at that graph. Remember, I stored it in y equals, and I was on Zoom statistics, so I can hit graph and you'll see the logistic function. It grows and then it stabilizes. But it stabilized below the highest number, so this is the carrying capacity. That's as high as it's going to get. That is our 20,954. So let's look at the other questions here that we have to answer. Well, we want to find the logistic equation, which we have here. So let me go ahead and plug those numbers in so we can see the logistic equation and then predict it for 2030. So here's my logistic equation. Y is population, I'll call it pop, is C, 20,954. That's your carrying capacity, divided by 1 plus A. A is what, 3.2369. Times e to the negative bx, negative 0.14157x. I'm going to go ahead and change it from an x to a t. There is our regression equation. And we're interested in the population for 2030. 2030 t is 70. So I've got to ask myself here, what is p of 70? Now that's going to be difficult to go ahead and plug in and get everything done correctly. So I think I'm going to go ahead and use the calculator since I've already stored that regression equation into Y1. So what I'm going to do is go back to the calculator. I have it stored in Y1. So vars, Y vars, function Y1 of 70. What is my prediction for the population in Naples in 2030? It is 20,590.2. So we'll just call it 20,590. I personally believe that's going to be a low estimate. I think with the Great Recession, when the numbers changed in that odd way, that bent this curve down. All right. So what is the maximum population? Well, again, that's our carrying capacity, and let's talk about how we can think about that. So long-term carrying capacity of this is what we need. So we have our question again. Whoops. What is the maximum population, the carrying capacity? The trend over time maybe is a better way to write that for Naples based on this model. So the long-term population, maybe I'll change that. Long-term population carrying capacity for Naples based on this. Well, you'll look to see as t gets large, what's going to happen. So we have this function here, which I'll write down again. Pop is 20,954. 954 divided by 1 plus 3.2369 times e to the negative 0.14157 t. As t gets large, where it's 70, 80, 90, 100, 1,000, I get e to a large negative number. E to a large negative number, 1 over e to a large number becomes essentially 0. This becomes essentially 0 plus 1 becomes essentially 1. 2954 divided by essentially 1. The carrying capacity, or the long term, is just that number on top, which is 20,954, which we can also see on the calculator. So we had this graph, and if we trace it, I want the curve actually. So as I'm moving, what's happening to the graph? It's growing still, right? And it's stabilizing. Where does it stabilize? I need to have a bigger window, but I can get a bigger window. I'm only going to 66. Let me go to 200. And you'll see just how stable this gets. It really flattens out, and that's your carrying capacity. But again, this crazy dot here is the one that is messing up the model, because again, after the Great Recession, the population declined, which is kind of interesting to me, at least. Okay, so let's trace this around, and you'll see it's heading towards 20,954, as we said. Right. So that's our carrying capacity. That's the long-term prediction, probably flawed, but based on this model.